little bit about myself. Like I did all my education in EE, specification in like communications. Graduated from VirginiaTech in 2023 and December 2023. And in 2024, January, Angelos, my advisor, and we started this company named WayWave, and we've been working since. When we started the company, originally it was like, focused on R&D in 3 different tracks. The first one was high accuracy positioning using retroreflective tags. The gist of this part was to improve the positioning accuracy for AR/VR users using like pretty much like something like a RF mirror. They can carry an RF mirror and using the existing signal, Wi-Fi or like cellular or whatever exists, you can track them, which is great for any AR/VR game. The second path was again related to positioning, the second R&D track, but this time we wanted to attack the problem from more fundamental points, like change the way people do the timing using isochrones, which is like a very complicated mathematical concept in electronic or photonic oscillators. We wanted to change the way the timing works, and with that, we can improve the positioning accuracy. And the third topic was using Starlink signals. Just observe the Starlink signal because there are a lot of Starlink satellites in the sky and see what we can do with that signal. So following all these 3 paths, publishing some papers, writing proposals, we eventually realized that the third one, which was a passive detection using Starlink satellite, has the maximum traction and interest. So we kind of switched that project and focus mainly on that to have a product and be able to move forward with that. All these 3 projects also rooted during my PhD time. So I was familiar with it to begin with. Now, the next slide. Okay, so what's the problem? Why that was the most important project to choose? If I want to summarize in one sentence, aerospace threats are growing rapidly, on a daily basis, but the detection for them has not catch up yet properly. So around 2018, we start to hear that there are airport shutdowns or flight cancellation, flight delays purely because of drone sighting. Nothing military, nothing crazy security threat, but just hobby drones flying close to the airports. But you have to cancel the flights because of that. Moving forward, drones start to be used in more illegal activities, like criminal use for drug smuggling or cartels close to the borders or for the prisons. Moving forward, drones got even more kind of military theme, using them in different type of wars, from Ukraine-Russia war to mass attacks to coordinated attacks to nowadays you can see that the war pretty much doesn't happen on the ground. It's in the airspace, from using drone, missiles, fighter jets, stealth bombers, and all those things. Everything is in the sky. And so we need to be able to detect them. That's why this is a very hot topic that we need to pursue. If I want to give you a very visual picture about one of the airspace threats, which is the drone, with numbers, and needless to say, this is not the only threat. This is the one that you can actually easily visualize because the public data is available. I cannot find data about how many hypersonic missiles is in the sky right now. So, but about the drone, visually, it was FAA registered drone with in 2025, it was 1 million. And this number in 2027 would be 2.7 million, almost 3 times. Now, this is the pace of the growth of this, just drone industry and FAA registered. I'm talking about the legal ones. Now, below 1% of all the calls that DHS and DOJ receive to counter drone for drone sighting, please help us. Below 1% of it can actually respond. As a result, there are so many incidents on response. For example, more than 3K incident of drone sighting since 2021, right close to the airports, which means that flight delay, airport shutdown, or flight cancellation, all those things. Or more than 27 K incident of drone using like close to the border, southern border, like in this last 6 months of 2024. All these things, again, emphasize that like how big of a problem it is. And if it's a big problem, why not people already, like, no, why not people working on it? So it's not like that. There are different methods that has been working on it, like some of them pretty much everyone is familiar with. The most important one, the flagship one, is radars. You can use radar to detect any object in the sky. The way that the radar works is that they transmit the signal hit the object, whatever it is, bounce back, you see the, like, you see the bounce back signal, and based on that, you can detect something. It's a flagship technique that is good, but there are some issues. Number one, they're extremely expensive, like, the order of like millions of dollars. Imagine this, you have like this summer, there's like FIFA, like, the football games in the United States. You cannot have like just for each game bring like $10 million radar right next to the stadium and then have to move it again for the next one to the next stadium. And also these radars, for them to deploy, it takes a long time, like within months. It's not easy to deploy and handle. So that's the most issue, that's the biggest issue with radars if you want to use it for just sake of like hobby drone detection. Doesn't make sense. The other well-known like path to do this detection is using the passive RF. The way that it works, they listen to the communication link between the drone and their ground controller, and based on that, you eavesdrop on that signal, and then you can sense the presence of the drone. The problem is, what if the drone flies autonomous, like without transmitting any signal? Or what if you want to use this technique for other threats that they don't transmit to begin with? So you cannot use them at all. The other famous one is like the visual, using cameras to see what's going on and then detect the presence of like the threats. The problem with this is the visual-based techniques are very high maintenance, both in terms of like they are costly to maintain, and they're high maintenance in the terms that they require the perfect scenario for you to work. If there is like a perfect line of sight, lighting is good, like there's no fog, no rain, everything is great, they can help you and say, oh, there's something in the sky. But that's not the case in day-to-day life. That's why we propose our WayWave solution, which is much cheaper than the active radar. It doesn't rely on any transmission from the object. It doesn't require like line of sight or like the daylight, or like it can work in any weather condition. That's why that's something missing from the existing literature. Now, to make the problem a little bit more like intensify the problem a little bit more, the way that radars work, as I said, like transmit a signal, listen to the bounce back signal of the object. Drones, they are very close to the ground, like a hobby drone. And there are like the RCS, which is something that this parameter define if a radar can see something or not. Their RCS is pretty low. It means that radars usually cannot even see them because the resolution of like that radar is not as high as seeing that small of object. And since they are close to the ground, they might be like, get pretty much lost in the clutter. So radars, even with all the good things that they have, they might not even be able to detect that drone. So that's for like the low altitude threats. In the mid-tier altitude threats, like stealth bombers, the way that they work is geometry of their, like, the design of their body and the material that they use is in a way that like when you transmit something to it, when it receives that signal, instead of bouncing it back to the radar, they just absorb it. So nothing go back to the radar, they just say, oh, the sky is empty, but they are in the sky. So the radar cannot even detect that. And more serious national threat, like in like a higher altitudes, hypersonic missiles. They are going super fast. In that scenario, they become anti-radar due to their high speed and high range, like super high altitude. So radar cannot detect them. So these are the stuff that exists in terms of like the airspace threats, but there is no detection for them now. So how we solve this problem? If I want to make like our solution, explain it like very simple, imagine there are so many satellites in the sky. The LEO satellites from Starlink, OneWeb, soon to be Amazon LEO, formerly known as like Project Kuiper from Amazon. There are so many of them in the sky. And they are transmitting signal to the Earth 24/7. So with this number, we can pretty much guarantee every point on the ground has access to so many of these satellites at every single moment. That means that if I want to like make an analogy, imagine those 6 satellites as like a source of light. Ours, our Earth is lit up by those satellites 24/7, no dark time. So no point on the ground there's no point on the ground that there is no access to those satellites. So the ground is fully lit up. Now, if an object passes between where you are, your eye, and the source of light, you see a shadow, right? And that shadow is pretty much what we are doing. So now back to the real thing, like there's no light, it's like RF signals, and there's no shadow, it's like disruption in the amplitude of that signal or the frequency of that signal. But based on these 2 disruptions, like very like briefly, that's how we detect, okay, there is something in the sky. And for example, this is its speed, this is its heading, this is its size. We guess it should be like this item. So go and look for it. This is its location, go and look for it. And now people say, okay, what about those ranges? This thing, like no matter where the object is, it makes a shadow. So even for the small drones, it makes a shadow. And all our actual field tests are with drones because that's the only one that we can actually do easily. So drones and the commercial airplanes. And we see the results. Then the Meteor one, the stealth one, they are designed to have no bounce back off them. But like in our system, we are looking for the shadow. They make even like a darker shadow, as in like we can say, okay, there's something in the sky and the shadow is pretty good. Probably it's like a stealth item that absorbs all the signal and I see like a big hole in it. Or like further higher like items, since we are using the satellites in the LEO, which is like 550 kilometers at least above the ground, anything between that you can see. So there's no problem with like, higher altitude threat as well. That's like the biggest of like how we do it. And I think I pretty much covered these slides as in like how it works using the Starlink satellites for now. We can connect to any LEO satellite, Starlink, OneWeb, whatever. Right now we are doing Starlink because that's like the majority of the satellites in the sky pretty much, like more than 9,400 satellites. And not all of them are like transmitting, but like a good amount are transmitting. And so like that, it's like a lot of them in the sky. And we take the amplitude and like frequency changes, and based on that we can detect the object. The picture that you can see is like for one of our setups and the drone that we are using to do our tests. And the 2 other pictures, like in the right part, the top one, it shows that like any sensor that we put, it makes like a dome of protection around it. And based on that, the size of the dome, we can like detect anything from like low altitude drones or high altitude like commercial airplanes or anything like above that. And yeah, so what is the key feature of this way? Like why this is better than radar and all other stuff? Number one, extremely low power because we are not transmitting. Transmit is the source of power. Power, like the system is power hungry if it needs to transmit high frequent, high power signal. We don't transmit anything, we just like listening, so very low on power. It can detect any altitude from above your dish all the way to the satellite. So wherever you put your dish on the ground, so it's going to be from ground to the satellite. You put it on the roof, from the roof to the satellite. Any point in between that. It can also see the stealth object, as I explained before, because they make like even a darker shadow. And it's extremely easy to deploy. Like the whole system has like 3 main components. One dish, one satellite receiver, which is like another big thing. I can put it in my car and go and install it somewhere. One small box that take care of like the signal processing, the STR box, and one computer that take care of like actual, programming of how to do this thing. So these 3 items compared to like a radar that needs like a truck to just carry it and then deploy it, like takes like so long. It's extremely cheaper. Like if radars is like in the order of like millions of dollars, this is like in the order of like tens of dollars, not millions of dollars. Like let's say with 25K, you have a full setup. That's it. And it's software defined, as in like the repairing of like for improving the system, you don't need to go there and change your hardware, which is like a big issue. You can easily just change everything purely based on the software. So all the improvement, it happened by software. You can remotely apply it to your current system. More advantage that like can actually attract the attention is like it's undetectable as well. Like one thing that I haven't mentioned yet, but it's very important, is like in a time of war or like adversaries try to attack you, you use your radar to see the adversary. But that means that you're transmitting a signal. The adversary can also see that signal. So, okay, there's a signal coming from this location. So there's a radar. So that would be the first target of the adversary and make the adversary blind pretty much. Instead of doing that, if you don't transmit anything, so no one can see you. I can put these setups like easily anywhere on the ground, like, on Earth. And it can also pretty much provide its own power using solar system, because since it doesn't transmit, you don't need much power. And boom, as long as I do that, I also have like I can see everything from that point, and no one can see me, fully undetectable. And in terms of like what's the coverage, pretty much the entire Earth, because like the Starlink satellites are everywhere. So I don't need to worry about like, oh, in this place I don't have like enough coverage. In this place I don't think, no, there are like so many satellites, so I can pretty much cover the entire place. These are the two like very important advantage of the system. Now, why now? Why not? No one else has done this before if it's so cool. Because a decade ago, there was not so many satellites in the sky. That's the whole thing. Like it was like 300 LEO satellite total. But recently, like very recently, with this like extremely fast growing number of satellites in the sky, that very important. We are not paying for it. We're just like using it. Like we don't even need to buy a subscription from them. They are there. They have like a lot of satellites there. They sell subscription for people to use the internet. We don't pay anything for putting the satellites. We don't pay anything for the subscription. We're just like using the existing RF signature. That's it, which is there for free. Pretty much we're using all those money that they're putting for free. And so that's why now it's the time. Like when we start this project, I think it was like around 7,000 Starlink satellite. Like in 6 months, it turned to like 8,600. The next time I was presenting, someone told me your number is outdated. Now it's like 94. And like, so it's like a monthly increase in the number of satellites. And the graph I think showed like in few years, it's gonna be like more than 40K satellites. It means that like, I don't think there's any place on Earth that you can go and not be seen by these satellites. That's like one important thing. And so there are other reasons as well. Like passive sensing is scalable because it's software defined instead of like being hardware based. And airspace threat also increasing. Like 10 years ago, using hobby drones were not that like popular. Some people had it, but nowadays everyone can like buy like a hobby drone for like $200 and then just play with it. And yeah, who knows? They can go like close to the airport and then problem. And to kind of like prove that we are right, recently there's like a huge shift in like defense budget for going toward this direction. And the Golden Dome, like $151 billion money that they assign for it through MDA is like one of the other signs that people like national security cares about this. So they want to spend money to make sure it's working. This is some of our live deployments. The left one is the one that we did in Kentucky as one of our actual customer. And this is like, as you can see, there's one dish, one box, which is like an outdoor server cabinet, if you wish. It has like, it provides a very good and comfortable environment for whatever is inside it. It has like an AC, heater, like dehumidifier, pretty much better situation than my actual apartment, honestly. And we put our SCR and laptop and everything inside that, and it's weatherproof. And then we have like a small dish on top of that. That's like a Starlink. We don't need that. We put it there to provide internet connectivity for remote access. It can be like a Starlink dish. It can be like a 5G hat. It can be like a cell phone, or it can be like, we prefer like something wired, like Ethernet. But like if we cannot provide that, we can use our own Starlink. And the cinder blocks, I know they don't look pretty. But like the setup is like very lightweight against radar. So if I don't put them, like wind just pushed away. And then the right picture, one of them, the middle one is a setup that we have in this area, like in Northern Virginia, Tyson's Corner. We have like the dish on the rooftop of our warehouse, and we keep all the SCR and computer indoors, and we do the cabling through like the chimney pipe. So that's one type of setup that we can do if we have access. We don't need the like outdoor weatherproof enclosure to put our stuff in it. And the right one, the most right one, is like another setup that we have in close to Blacksburg. And that's like a fully standalone setup, similar to the Kymeta one. That one is also like, the dish, everything is in the box. That's like one of our earlier deployments. So we didn't have like a fancy box with a good enclosure. We just put everything in it, and then we say, hopefully the temperature is good. But like, because this is like for years ago, like, for a while ago. The KY is like more recent. And then again, the Starlink there because to provide internet connectivity. In terms of like how is the company doing right now, there are tractions. We have, like, as I said, we have live demonstrations that we can both show it to customers, play with to develop, which is like Northern Virginia and Southwest Virginia. We have active customer, Kentucky. They are looking for like a big project to pretty much cover the entire state of Kentucky. That means a lot of like systems. Like so far we focus on one of them to show it to them, but like it's gonna be like a big project. And we have upcoming deployments in Virginia, like Stafford, like the airport for the Stafford, like small airport in the Stafford. And we have like active like meetings with Amazon. There's a project, Amazon Leo, formerly known as like Project Kuiper. They want to become like something similar to the Starlink. They want to have their own satellites and terminals. And our goal is if we can use their terminals and put our software on it, then we don't need to buy the dish or like all those extra things that we need to buy to put our software on. We can just use their thing and put our software on, and it's going to be like a full package done. And we also have like an active talk with MWAA, the Metropolitan Washington Airport area, like the airport authority that covers like the DCA, IAD, and like to put radars, to put our system for them for drone detection, drone sighting close to the airports. So these are the stuff. And with that being said, thank you for listening.
Yeah. Maybe we can take a couple of questions for Alireza first. Yeah.
So that was great and very timely. You raised all the issues, and you probably know all of that's going on with Golden Dome and so forth. So I'm curious so I have a technical question about, sort of, is there sort of limits in terms of the speed of the object that you're looking at? So that's the technical question. But I'm also interested in the business side of this, because part of this is that I think the goal is to grow this into a business, and you didn't really get into that. And if you just say a few words around that as well, thank you.
The technical one, actually, that's a very interesting question, because usually it works the other way. Like higher the altitude or faster the object goes, it's harder for regular radar to detect. But our detection, I'm not going to get into like the super like mathematical background, but like the gist of it is we are using Doppler shift, and the satellites, they have a Doppler shift already. So based on that Doppler, we have that. If any object pass between the satellite and us, it change that Doppler, come on top of that Doppler and make a change on it. And higher the object and faster it moves, it makes a bigger Doppler. So it's pretty much similar to the, again, light analogy. Like if you're closer to the source of the light, the shadow is bigger. So you can watch it, like, you can observe it easier. So the drone, honestly, the small object that is like close to the ground and that moves slowly is the hardest. And we are working with that. Theoretically, I haven't detected any like, hypersonic missile yet, because I don't have the access to the information that such a thing exists right now to, to validate my data. But theoretically, that's easier to detect because the Doppler is bigger. So like for me, it's much easier to detect that object with its speed. And in terms of like the business, yes, like we are working like very hard on the business side. Like recently, the path that we are pursuing is like proposal from governments, like SCIRs and different proposals. That's one path. And on the same time, talking to VCs if we want to raise money for Series A for our project. Like a 2-year-old project, and it has already some investments, but we want to raise more money for pursuing further.
I have another question. I'm just curious. Do you have a patent, or is there any plan for a patent?
Yes. Good question. I usually have those slides for the VC deck, but like not for like the shorter talk. Yes, we have 3 patents already filed, like patent pending. That's very important. And they are both domestic and for international, because we also collaborate with international companies, like specifically South Korea and Taiwan for our hardware, possibly hardware change from like our current dish to their dishes, because it's cheaper and it's make it easier for scale. So we have 3 patents pending. And whenever we want to talk with these people, the first thing we do is like NDA, MNDA, all those things to, again, make sure that, it's make it harder for people to replicate.
Thank you. Any other question?
Thank you. I really enjoyed your talk. I kind of heard you speaking a lot about Dopplers and then kind of just how the different, I guess, objects you guys will be seeing across the radars might form. Have you thought about or redone any modeling or algorithms that will be able to easily tell the difference between if you're looking at like a radar or a plane versus if it's just like a bird or something that does not pose a threat at all to the system?
Perfect. So that thing is not taken care of by Doppler alone, because Doppler, it makes a shift in the frequency. As in, like, if you want to like very briefly imagine this, like there is a line, and then when an object passes, that line get broken, go somewhere else, and then back to normal. That's how we know that something passed. And we can also calculate the speed of the object using that, like simply. But about the size of the object, or if it's a bird, or if it's like a quadcopter, how many rotors, the length of the wings, all those things. There's another concept named microdoppler, which we also have that. And with that, we can analyze, like, provide more information about the object that passed and distinguish between birds, clutter, drone, airplane, all those.
Another question here?
Yeah, thank you for the presentation. I'm just wondering what type of like noise or sound you use like for the radars, like to detect like the objects.
No?
Like noise, like white Gaussian noise or anything like
Not fun. What noise?
like what type of noise or like wave, like in terms of
Wave or no? They're two different. Like,
wait, do
wave?
you use either use like a wave or a noise?
You're using wave.
Okay.
Like,
Yeah, what type of wave? Like
what are wave? That's a very, like, that's something niche about the system. I'm not in control of those waves. Who send those waves? Starlink. So whatever wave they send, I use it. And you might say, okay, you have to design your antenna for demodulation, decoding based on that wave. The beauty of it is I'm not doing any decoding or demodulation. Like, I don't take a look at the content of the signal. There is this RF signature. I have an antenna that can capture that. I know the frequency is between 10.7 to 12.75 gigahertz. That's the frequency range, but it changed during that frequency. I have a system that strives for that frequency, knows all the sub-frequencies that the signal gets sent in on those frequencies, and then just listen to it. But there's no demodulation or decoding, so that I need to know what exact, like, modulation technique they are using. It is like BPSK, QAM, whatever. I don't care. As long as there's a signal in that frequency range, I can see the signature.
okay, thank you.
So I don't think you are listening to the signal. You don't know what's being sent from Starlink. Yeah.
Okay, from online, how hard or easy is it to defeat the LEO satellite signal?
Defeat?
Mhm. This is defeat, jam, the LEO satellite.
Oh, jamming the LEO satellites. We are not working on the jamming, but the good thing with LEO is for jamming, you need to send like a super powerful concentrated parasite signal to that area. LEO satellites, they are moving fast. So like for each like satellite, when we lock onto it, maximum of like 3 minutes to lock onto that one. And then we switch to another one. So even if they jam that one, we already go to another one. Like, so, and also the 3 minutes that I'm talking about is like the perfect scenario. Usually it's like much less than that. Like every 30 seconds, we switch our satellite. So think about it as like a frequency hopping technique, that to avoid jamming or like interference or anything, instead of focusing on one frequency all the time, you hop among frequencies, and no one knows with what frequency you do these hops. So that's how you, like, counter that. But like we've never seen like in this year and a half that we've been working with this, we've never seen like a jamming happening to our signal. So
Okay, one more from Zoom. What are some of the challenges you are still working on to make this work?
oh, that requires like another talk probably for like a day or two. But like no, there are so many things. Like this is like every day we go, we are constantly changing our, improving our code from the small stuff like the beacon detection of like the satellite as into how to track satellites better, faster, with more resiliency, to detecting different objects. Okay, we can do the drone detection. Now, how can we distinguish between different drones? Why not, buying different drones, try them all and see the different signature of the drones to have like a better data set for ourselves. What if we can actually, for example, match the flight record of the commercial airplanes, which we did like to some level, and like listen to those timing that they're passed by our system and see what we see, how accurate we detect that. These are like from the technical side, to also constantly looking for convincing people to this is a good idea, and let's the VCs and to raise money. So
Any successful detection stories you can share with us, like in an airport or something?
Yeah, like the system that we have, whenever we go there to like our system, we fly a drone and we see the detection. Like we have that. And for the commercial airplanes, yeah, like we saw like it started like very random, but like then we do it on a regular basis. But like it started like this. We saw like a big shift in our frequency, in the frequency of the signal. And then we were like, okay, we didn't fly any drones there. So what is this? We did the calculation based on the height and speed of that object. It was like a commercial airplane. And then we checked the record, like the commercial airplane available on public. We say, yeah, there's something passed by that time, and it confirmed that. So that's how it starts. Like, and we realized that, okay, how big of a change you see in your frequency when something passes.
Thank you very much. This is really exciting and fascinating. Thank you.
Thank you.
Yeah, so I call it kind of from lab to launch. But yeah, so basically, my journey kind of started in academia, right? I got my PhD in VirginiaTech, focusing on a very specific and niche field in cellular networking, right? I was focused on 5G testbed construction, security, open security, general cellular security with cloud native network orchestration. And I was kind of very much invested in publishing in top venues and kind of proving that my novel ideas were the best, right? And then I switched to the industry path, and I was kind of fortunate enough to be provided by our advisor, who's kind of very much plugged into what is going on in the government, and he kind of got me involved in this DARPA open programmable and secure 5G research, which allowed me to kind of collaborate with a bunch of different researchers from all over the place, right? That eventually led to the path that I am on. So, okay, now that I see it, it's actually, okay. I had some winder weight on, and it's a bad angle, so I don't want to be judged, I'm sorry. But then, yeah, so the DARPA OPS 5G, it started back in 2020, 2021. And so, as I said, it was building the testbed and everything. And then once I completed my degree, we were involved in a very new and emerging program that was called the DARPA EEI, which stands for Embedded Entrepreneur Initiative, right? And basically, this is where we write a proposal and we basically submit it, and they will appoint us they will actually appoint us an advisor in order for us to find an already existing and accomplished entrepreneur from his previous life to come and help us with our own business development. So that is exactly the journey that I'm on right now, right? We're kind of in the middle of it a little bit. But this took like, a year of due diligence to basically convince them that we are both technically and business-wise savvy, right? And obviously a company is born, well, almost born. Right, so the company, the incubator behind all these ideas, both like WayWave and what we're trying to do right now, A2 Labs is Angelo Stavros' company, right? So it's kind of a VC-backed it has an existing track record with success in this commercialization field. But so yeah, before I move forward, from now on, I will be starting the actual pitch. But as I said, I'll be doing it in a bit of an interactive commentary, right? So this is the slide that is basically supposed to explain the problem to the people, right? And it's supposed to explain it in such a simple way that everyone can understand it. Because the very first time I was doing this slide, I think it was not good and people were not happy, right? And because I was explaining it in a very technical way. So if I were to explain it now, you can imagine your internet, right, which everyone knows is a house of cards, right? At the very bottom, you have your connection, which can be anything, right? It can be your phone, it can be your Starlink dish, it can be your fiber that you have at home. And then this consists of various different cards that make those connectivity options kind of a viable option, right? And there we have the kind of, technical terms where it's a single path, multi-path, you can experience session drops, whatnot. And then one layer above that, you have your applications, right? So you have, your Netflix, your what else, that need to be steered in the optimal way. And then they need to be able to select paths without you having to interfere with them. And then these kind of have these cloud path control, because in this day and age, yeah, there's no invisible magic angel that, takes your packet and kind of just puts it where it's supposed to go. Everything goes through the cloud, everything goes through AWS, everything goes through the Microsoft Azure, everything goes through the Google Cloud, right? So that is that layer. So you have your geo-locked, your IP, because your internet identity is kind of, rigid. And then you yourself, don't really see how it goes. And then you have basically the thing that everyone is gunning for, basically zero downtime. And the problem with this house of cards is if any one of these cards is kind of pulled back, everything will collapse. Now, so this is the initial statement of the problem, right? As we move forward, this was still not resonating with the layman, right? So we came up with tailored stories that would resonate with every single customer segment. So I'm going to go through these stories now. The first story, right? You're at home, it's a football game, it's a Super Bowl, right? You have your friends over, and your cable dies. And it won't die for a long time, but it will die for like 2 minutes. And then I honestly cannot think of something that is worse for football fan than something like this happening. I think it would be quite chaos, honestly. Right? I mean, if this were to happen, I think you're home, you're embarrassed for your friends. Oh my God! So it comes back on, but I bet people won't forget that this happened. So with the solution we are providing, this will not happen. So it basically saves your sanity, right? That's one. And by the way it works is you will be able to switch over to a backup, which you don't have to think about instantaneously, which we would be providing. The second story, right? We are kind of just living in a world of digital nomads. Everyone travels all the time, internationally, nationally. So let's say you're on the road, right? You're at a hotel in London, and half your Netflix and half your news is gone. I honestly, this happens. I think people don't realize that this is a big deal until it happens. But if you're in Spain and suddenly your news is in Spanish, that's actually very annoying. I don't appreciate that. And then, so in an age where you have close to 19 million digital nomads, where they're have to rely on these VPNs to basically do what they do, and these VPNs are never really service oriented. This will kind of save you the time to basically, without any configuration, without anything, it will know what application you're using and what application should go from where. So you're in London, your Netflix content will be there, your news will be there, but at the same time, you don't want to route, for instance, your maybe important Zoom call all the way from your home location so it doesn't lag, right? So second, it saves you time. And then finally, for a more business-to-business perspective, right? Let's say you are, the manager of a Wells Fargo branch, right? A retail bank branch, right? So there's a construction going on nearby and a fiber is cut, right? Your network operations are down. So in this modern day and age, they say that if you want to induce chaos in a country, you should basically turn the lights off, and by lights, the internet off in that country for a day. I think it would be more catastrophic than we all realize right now, right? So the same goes for, at a smaller scale, obviously, for these small branches of these large corporations or even small to medium businesses. So at that point, again, you will be able to switch without losing any kind of without any kind of inducing operational downtime, any kind of backup you have. So in this case, the advised one is maybe satellite dish, which is not necessarily the fastest option, but it's always there. It's always seamless. So these stories were kind of tailored for various different customer segments, basically ensuring that the story and the problem resonates with almost everyone. And the why now is the following. So this is one other very important aspect is like, what is the rush, right? What is both the rush and why is it so timely? Because like right now, this type of downtime causes close to like $400 billion in basically, well, revenue every year, right? What makes it viable now is cellular is much more widespread, right? 5G transitioning to 6G now. It's much more affordable at scale. And the existing solutions, which there are, and you will see in a moment, right, we call them software-defined wide area network solutions. They're too complex and pricey for essentially these kind of small businesses to afford, or should I say the actual consumer or prosumer at home to afford. And finally, everything, every single service, everything you use, trust me, Netflix, Zoom, everything else, it goes through a cloud point, right? And right now, no single product on the market kind of solves all these three customer segment solutions until, well, we kind of step in. And yeah, so to actually summarize what the solution is, right? It is a platform that makes your internet bulletproof by managing and optimizing network application traffic for always on location aware connectivity. So on the left, you have your connections, right? So you have the cable, fiber, cellular, which can be 5G, 4G. You have the satellite and the Wi-Fi, right? Kind of synonymous to fiber a little bit. But then our edge controller, which we have come to call the VVN edge controller, it will sit between these connections and it will do four things. It will, one, pull all these connections into one pipe, send each app on its best path, because right now, everything kind of uses the same dumb pipe, and we don't want that. We want the apps to basically be tailored, or should I say the pipes to be tailored to the apps. And if anything, goes wrong, it switches to the fallback option in under a second. It's actually kind of funny. I am demoing this product at my home right now. I have this thing set up at my home, so I'm using it. And honestly, I had an important meeting to take the other day, and I kind of felt like, I don't know if you saw it, there's a meme of engineers who built the brakes for a tank. They're kind of standing, like holding hands in front of the tank as the tank rushes towards them. And there's like there. And I was like, hey, what, it goes out now? And then I'm like, it didn't go out. So I was able to make like a kind of a statement to these people. Yeah, in this meeting that you're funding us for, I am demoing the product that I'm promoting to you. So kind of a power statement. And then last but not least, it kind of makes you appear wherever you want. And by you, I mean the apps which are sitting on the right side. And if I were to summarize the features in a more technical fashion, I would say it does multi-connection pooling, per app geosteering, cloud anchoring, and it does it with zero config without any kind of, let's say, thought about it on your end. And obviously now we move on to the more kind of, I say, necessary slides, I say, boring slides, I'd say. So we have had to do a market analysis. We have had to kind of, figure out both the total addressable market, which we identified to be the global software-defined wider network and resilience market, right? And it's projected to reach 192 billion by 2030. And the service addressable market, which is an $8 billion market, more sustained to the multi-WAN and edge resilience. It's similarly has a very aggressive growth rate, and it's $8 billion by 2030. And then the actual service obtainable market that we are aiming for, right, an actual annual revenue is a $50 million market, which is the small to medium businesses, retail branches of these large corporations, and the consumer prosumer market. And the converging tailwinds to these are, meaning that the supporting factors is that the integration, I mean, there was a conference recently in Barcelona, it's the Mobile World Congress, where it's basically like the expo for mobile news. So basically there it was said that Starlink, well, is announcing that they're partnering with cellular, like your T-Mobiles and your Verizons, to basically bring or merge satellite connectivity so that they can be kind of more part of the every day-to-day internet flow. And similarly, the 5G enterprise rollout, the cloud dependency, and the, kind of unavoidable AI workload latency, which is kind of, driving, I think, affecting all of our personal devices now. Because if you try to go and buy like a personal computer, it's way more expensive because, the manufacturers have prioritized basically the prices for server-grade materials rather than personal user-grade materials. So workload latency, and finally the security aspect, where you want to be able to trust where your traffic is flowing from. And Yeah, so obviously, I mean, we are not the first to think of something like this, right? I mean, there are many solutions that have that are trying to achieve something similar. And you kind of see this positioning map that we put together, right? It's both the y-axis, you see the resilience and session continuity aspect, and on the x-axis, you see deployment simplicity and accessibility aspect. And there are always these solutions in these quadrants where, so the top left quadrant would be your enterprise resilience, the bottom left would be your legacy enterprise, kind of, more simpler solutions, sorry, more complex but shallow solutions. And then the top right quadrant is the sweet spot we're trying to reach, right? It's the simple but actually strong and deep solutions. And there are not as many solutions in that space as you might think, in the sense that both providing the enterprise-grade resilience that you want, but also accessible to the end consumer and the small to medium business, right? So that is actually very much not an unexplored, it's very much an unexplored market. So to sort of summarize with the outro, it's like the enterprise SD-WAN, it's kind of an overkill for you guys if you want to buy something like this. And the consumer multi-WAN, which we have kind of benchmarked some of the solutions, is just plainly dumb, right? It doesn't really, do what you want. And honestly, it's not super clean. And just again, how would we actually market this, right? So we have come up with, I mean, obviously this is in beta, but we have come up with some ways to basically tell to the people, okay, these are the options for different customer segments. So obviously for you, who you are already paying for, let's say, I don't know, $50 to $100 a month for internet, right? You would maybe want to pay, depending on a tiered subscription, maybe up to $20. No one's going to pay like $100 for something like this per month while they're only paying $100 for internet to begin with, right? But that's how we do it, right? We basically adjust these solutions complexity based on who we're marketing to, like its ability to basically be, available or more robust shifts based on who's going to buy it, unfortunately. So a small business will be getting a bit more capability, right? And then obviously for enterprise and government kind of contracts, which are more annual, we will be providing the best kind of support. But I'm only presenting these numbers to sort of give an idea about the process of trying to define, let's say, a business model to someone who's going to be interested in investing something like this, right? These are the kind of necessary, but unfortunately boring slides that need to be made so that, people see that you have an idea about, what you're talking about. And similarly, like go to market, honestly, I'm just gonna kind of glaze over these. I don't like these slides, I'm sorry. So I just wanna talk about a team a little bit because I'm really grateful to the team. And in fact, so obviously there's Professor Stavro, who was our PhD advisor, right? He's still here. He actually teaches an entrepreneurship course. I'm not sure if anyone here. Okay. But yeah, so he's the kind of one who's leading this incubation company that allows all these other companies to spin off from it. And then, yeah, there's me. I have a colleague, Dragoslav, who I worked with throughout my PhD. And then we have some new people who joined us along the way. And here's the thing, which I will show in a minute, right? I think it's very important to find people who complement you, because sometimes in grad school, people tend to get very, very conceited with their technical expertise, and they forget that there are other skill sets required to make something like this real. And literally just 30 minutes before 3, so I had a meeting from 2:30 to 3 a.m. Sorry, p.m. This is an anecdote, but it went bad. That meeting did not go well. And I got some bad news. I'm not going to share the news, but David, who's very much experienced biz dev, he said, you know what we call a curveball in startup world. He said, we call it Wednesday, right? And then basically, if you're able to hit a curveball, right, you have more prestige in the end. So just keep powering on. Yeah, where we are today in terms of a prototype, we have achieved technology readiness level 5, which essentially means that we have deployed the first prototype and tested it at a specific scale, right? The scale is always, never specified. And we obviously have the Embedded Entrepreneurship Initiative in progress, where we have an experienced biz dev person providing us support and resources for us to basically pursue investment or fundraising. And then finally, we have government outreach as well. We're trying to basically bid for contracts where they would support us with in a more formal and structured manner, right? So one such example is this National Science Foundation VINES program, where they are looking for cellular-oriented projects to basically further both the research and industry when it comes to this kind of research. And okay, this is actually, so this is like kind of a dialogue that I had with myself, where, you know, what nobody teaches you in grad school. And I wish I had this dialogue with myself kind of earlier. So first of all, like I used to think like my PhD research is my product. I used to ship it. See, that's not true. Like your research is your defensibility, not your product. Nobody buys a paper, regardless of where it's published. Like regardless if it's published, if it won the best award at the best conference, nobody will buy that. But you can be like, yo, but I have the deepest technical expertise in this space. Yeah, well, can you explain it to a technical buyer? Can you explain it to your niece, like that is 5 years old, without them throwing Lego blocks in your face? If you cannot, then they won't buy it, right? And then I kind of put this quote up there. It's a quote from Prestige. It says, like, the secret kind of impresses no one. The trick you use it for is everything. And then finally, so what do I actually need to figure out first? You need to find one person as the initial step that is willing to pay for it. Not someone who's going to pay for it, someone who's willing to pay for what you build, right? That's your first milestone. So to summarize, academic rigor is your moat, layman clarity is the bridge, and a paying customer is the proof, right? Basically, well, the castle. And the playbook that I wish I had when I was kind of embarking on this journey is, I wish I knew that the incentives between like academic publishing and the product, they kind of tend to pull you apart at points. And while it would be great to balance them, you have to kind of just pick your season and then just concentrate on it. Second is that your co-founders are your superpower, right? I mean, I'm relatively certain that everyone in this room is pretty technical, right? You have very much depth in your respective field, but if you cannot like find someone who will market it or teach you to market it, then unfortunately, like if you cannot articulate what you're doing to someone who doesn't understand it as well as you, then there's no way forward. And then yeah, IP, intellectual property, is a leverage. It's not a product, right? Obviously, provisional and provisional patents, these things protect you, but you kind of need to make sure. I mean, there's no need to just kind of keep filing patents without any actual solid idea that is in the center. And then, yeah, you can like start while you're here. I mean, I'm pretty much sure that VirginiaTech really does provide a good environment. I mean, this kind of building is a testament to it, right? So it does provide the good environment for entrepreneurship, right? It's called the Innovation Campus. So, and yeah, I don't think there's a bad or an early time to start if that is what you want to do. Yeah. So thanks.
Any question? Any questions, Zoom?
I have one question.
Thank you very much for the talk. So I had a question about the Weavian tool. You mentioned that the pipes pick the best path for each application. I'm wondering, would a user be privy to those locations or those paths that it's selected?
No, so there are two options. I mean, I do not say it because what an investor wants to hear is the zero config part. So technically, it has an automated set ready version that comes to just plug and play. But yes, as an advanced user, you have the ability to control everything if you choose to. But the average user does not want that. So yeah.
Thank you.
Any other question? Yeah.
As a technical person, how did you come up with the subscription fees?
Yeah, I did not. It was not me, right? So that's my point. That's my point. I did not come up with those numbers. Our biz dev people, our marketing people, well, not marketing, but like our strategists kind of came up with them. David, yeah. So there was market research behind it, though.
Yeah, thank you for the presentation. I'm just wondering, like, how would you know, like, let's say you choose like two connections, like 5G or satellite. How do you know, like, which one's not working or not based on like the situation?
Yeah, so we have a degradation sensing that is set up that basically does health tests, periodic health tests on each interface. So it's basically, it's stated concretely, right? Starlink, when you have it, either it's a Wi-Fi interface that you connect to, or like it's a cable that comes out your like box, right? Or your, at that point, those interfaces are periodically monitored to make sure that they do not degrade below a certain threshold. The threshold actual value depends on what the application is, right? So whatever the application's needs are, because quality of service is kind of dependent on the application.
Thank you.
Question in Zoom?
Okay, on Zoom, how is your edge controller on the other side of the cloud from your apps?
Okay. I'll just interpret the question and
Okay.
answer it. So I'm understanding. So edge controller, you can think of it as a router. That's it. The cloud is the cloud, like it's an AWS instance. And basically, we have both software that is placed in the cloud, and then we have software that is placed on any kind of commercial off-the-shelf router, right? Just to sort of make it easier to imagine. And then basically, these two pieces of software that we have built, they communicate with each other to, well, realize the actual flow. I don't know if that answered the question, but yeah.